All right, here we are. Last video, I realized you might need this to complete your tutorial activity on Newton's laws. So here's the next video. What is gravity? This should be a fairly short one because we want to just talk about what is gravity on Earth, and then we'll get to orbits next class. Okay, so we have Newton's second law that it says an unbalanced force is causing acceleration, right? Well, on Earth, that acceleration that we feel from gravity is towards the center of Earth. Basically, we are being attracted towards the center of Earth by gravity. Okay? So the acceleration due to gravity, which we use this little g to think about, is the same for all objects as long as we're all on Earth. We're all accelerating at the same rate because of gravity towards the center of Earth, regardless of our mass. And this is where weight and mass are a little bit different, right? Weight and mass are different because we have this mass, this sort of I skipped too far. Okay. We have this mass, this sort of physical self, right? Weight is a force. It's a force on that mass. It's the force an object or you experiences from gravity. Gravity pulling you towards the center of the Earth. So Newton's second law, force equals mass times acceleration. The force now is very specific. It's weight. If you're on Earth, the force pulling on you is gravity, and so we call that our weight. And that's equal to your mass, still the same m, times acceleration, but it's that acceleration little g that we said on the previous slide. It's due to gravity on Earth. It's a very special acceleration. You can accelerate in your car, you can accelerate on your bike, but this is a specific acceleration. That's a times. So that's not an x, but a times. Weight is mass times this specific kind of acceleration on Earth due to gravity. It has a number, right? 9.8 meters per second squared. It has other numbers depending if you want to change the units, but you might have heard that one before. So force is just our weight times mass times gravity. When you step on a scale, you're measuring the force of the Earth on you. Just like in that clicker question, the force of the Earth pulling on you. I keep saying on Earth, because your weight changes if you're not on Earth. If you are on a different planet, you'll have a different weight. Because not every planet is the same mass. Not every planet has the same force. So if you're on a different planet, you have a different little g, you have a different acceleration due to gravity. Okay, this little g is not negative 9.8. That's why I gave you that number before. It's not 9.8. It's something else because the mass of the planet is different from Earth. You have a different acceleration. You have a different force of gravity, different than Earth. So here's the example. If you go to the moon is smaller than the Earth, right? The moon has a smaller mass compared to the Earth. So if it has a smaller mass, that means it's going to have a different acceleration due to gravity, and your weight is going to be less, about 1/6, actually a lot less. This is why astronauts can bound around on the moon, because the moon is smaller than Earth. Okay, we're not done with these ideas. We're going to apply them to orbits next. Got another video for you that I'm going to add on there, and when we come back about what is gravity, when we come back, we'll do some demos, we'll talk this through, we'll go over your activity. Okay, but that's it for now. See you back in class.